Hello student, how are you? I'm Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you some important problem on laws of motion. The chapter laws of motion, which includes Newton's laws of motion, friction and circular motion. So let's start about the class. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT JEE exam and NEET exam confidently with a good rank. Now let's start about the class. Here first problem is, here this block is split in this way, here force is 2F from right side and from left side force is F applied, and this section is at angle 30 degree horizontal, two equal parts two parts are equal mass. So what is the question is, what is the normal reaction acting between the two block? What is the normal reaction acting between two block? Now here you have to draw first free body diagram. So solution of 1, draw the free body diagram. So this and this draw the free body diagram. So if we draw the free body diagram, two equal mass m, here force is F, 2F, mass is equal, this angle is 30 degree. Now here important points is, what is the normal reaction act between two sections. So important point is, normal reaction acts always normal to the surface. So if this is R and this is R, normal reaction act always normal to the surface, that is this way. Now resolve this R into two components, horizontal and vertical. So if this angle is, this is 30 degree normal to the surface, R is act in this way. So we have to resolve in this direction and in this direction. So R is in this way. Now this is 30 degree, 90, this is 60 degree, this 60 degree. So this angle is again 30 degree, this angle is 30 degree. So here R cos 30 degree, R sin 30 degree. Okay. So if we draw normal reaction normal to the surface, now this angle is 30, 90, so this is 60 degree. Now this is 30 degree, so this is R, so this component is R cos 30 degree, this component is R sin 30 degree. So in this way, this is R sin 30 and this is R cos 30. Okay. Now write the equation of motion. If the two blocks moves with acceleration A in this direction, because this is great force 2F, because this is more force than this, so whole blocks moves in this direction with acceleration A. Suppose let the acceleration is A. Now what is the equation of motion? Here equation of motion, two force act in this direction, so R sin 30 for left block, R sin 30 minus F equal to MA, this is equation 1, and for right block equation will be 2F minus R sin 30 equal to M into A. Now add, so cancel this 2F minus F is F, 2MA, so A equal to F by 2M, F by 2M. Now what is the normal reaction? Normal reaction is denoted by R. So from 1 we get R sin 30 means half equal to M into A, F by 2M, 2 cancel, so R equal to F sin 30, this is half, minus F equal to M into A, F by 2M, consider, so R minus 2F equal to 2F equal to F, so R equal to 3F. This is the answer, R equal to 3F. This is the answer. Okay, so this is wedge B, and a block of mass and block A is placed over the wedge, angle is 37 degree. The acceleration of edge A, the acceleration of this block is given this, then the acceleration of B is what? Acceleration of B is what? This place, this is smooth surface. So if the blocks moves with an acceleration, then the block B moves in this direction, so that the block B moves in this direction. So what is the acceleration of block B? The acceleration of A is given. The acceleration of A is given. What is the acceleration of block B? Here also we have to draw the free body diagram. What is the this is 37 degree, 37 degree block A. If the block A moves in this with a velocity, if the block A moves with an acceleration, then block B moves in this direction with an acceleration. Suppose the acceleration of the block B is A. Now the pseudo force act on the block A is in this direction. So the acceleration pseudo force, that is, if the block is MA, so due to this acceleration is due to this block, the acceleration of block A due to this block is this. Now the acceleration of A is given 50I plus 50J. So 15I, that is this, and 15J in this direction, because this is X and this is Y. So what is the problem here? What is the important point? Important point is the normal direction, that is in this direction. In this direction, net acceleration of the block A is 0. This is the important points. Important point is the acceleration of block A along normal direction is 0. So now total force act on the block due to the acceleration of A is this. Now if the block B moves with an acceleration, pseudo force acting in this direction. So due to the block B, acceleration of A is this. This part is only due to the movement of block B. Now here the acceleration of A is given with respect to B, and the block A is always in contact with B. So there is no motion along this direction. No motion means net acceleration along this direction is also 0. So important point is then the acceleration of A remain. Important point is A remain in contact with B. So there is no acceleration along this direction. So acceleration of block A along normal direction is 0. So we resolve the acceleration in this direction. This is 15, this is 90, so this is 53, and this angle is 37. So this 37, so this component is 15 cos 37, 15 cos 37, and 15I. So 15I. Now 15I. So pseudo force act in this direction. So total acceleration along this A minus 15. Now this is 37 inverse. This angle is 37 degree. So component of this along this A minus 15 cos 37, 53. So 53, 37, 15 cos 37. this is OSB, this angle is 37 degree, and the block A is placed on the OSB. The acceleration of the block A is given, then the acceleration of B, what is the acceleration of BE? Now given acceleration of acceleration of A is given, what is the acceleration of B? So solution of 2, we have to, important point is that the here normal reaction, the important point is A remains contact with B. A remains contact with B. So there is no acceleration, no motion along the normal direction. There is no motion, there is no acceleration along the normal direction, along this direction, as A remains in contact with B. So if we draw this diagram, the block A, this is B, this is A. Now what is the acceleration? 15i plus 15g, x and y. So 15i means acceleration of A is given in, this is 15. So 15i 15j. Now suppose the acceleration of block B is in this direction A. Now what is the studio force act on the A? Studio force act on the A is in this direction. So the acceleration due to B, acceleration of is this. So 15 in this side, A is in this side. So net acceleration along this side is 15 minus A. Now what is the angle? So we have to make zero acceleration along this direction. We have to make zero acceleration along this direction. So if the angle is 37, now what is this angle? This is 3790. This is 3790. Now this is 53. This is 53. So this angle is 5390. This is 37. So this angle is 37. Now this is 37 and this is again 53. This is 53. This is 53, 90, 37, 37. This is 53. So 15 minus A cos 37, 53 equal to 15 minus A cos 53 equal to 15 cos 37. So 15 minus A equal to 15 cos 37 by sin 37 cot 37. Cot 37 equal to, what is this? 37 3 4 5. So cot 37 means 4 by 3. 4 by 3, 3 cancel. This is 20. So A equal to minus 5. So acceleration equal to minus 5i. Acceleration of block B equal to minus 5i. This is the answer. So here important point is we have to make the acceleration of block A along the normal direction, that is in this direction, is 0. In this direction, acceleration of the block A in this direction is 0 because A is in contact with B, so there is no motion along this direction. So acceleration of the block A along this direction is 0. For that, if the block B is moved with acceleration A, then pseudo force act in this direction A. So we take only acceleration. So acceleration of block A is 15. Due to this acceleration is a net acceleration along this direction is 15 minus A. Now this is 37, 90. This is 53. This is 53. This is 90. So 37. So 37. Now this is all 53. So this direction is 15 minus a cos 53. Now this angle is, from geometry we get this angle is 37. Now 15 cos 37. So this value is equal to this value, because net acceleration along this direction is 0. So this value is equal to this value, that is a equal to minus 5. So acceleration of block B is minus 5i. What is this problem? The problem is here a sphere of radius r, radius is r, is contact with a wedge. The point of contact is r by 5. That is the contact of point with wedge and sphere is r by 5 from the ground. The wedge is moving 20 meter per second. Velocity of the wedge is given. Then the velocity of the sphere at this instant. Velocity of sphere at this instant. What is the velocity of sphere? Now, if we draw solution of the problem, if we draw the solution of this problem is, the wedge moves in this direction as 20 meter per second, and the contact between wedge and the sphere is r by 5 distance from the ground. Now what is the speed of the velocity of the block along this direction? Suppose this is v2 equal to what along this direction? This wedge moves in this direction. The velocity of sphere along in this direction equal to what? The contact of sphere and wedge is r by 5 from the ground, at a distance r by 5 from the ground. Now what is the principle here used? It is given that this sphere will not separate from the wedge. That is, the sphere is always in contact with the wedge. The sphere is always in contact with the wedge. So the basic theory is that as the sphere is always in contact with the wedge, so that is along this direction, velocity of wedge and velocity of the wedge along this direction is equal to the velocity of the sphere along this direction. That is, relative velocity of the wedge with respect to sphere along this direction is 0. Now we have to find the velocity of the wedge and velocity of the sphere along this direction, along normal direction. So this is, if this angle is theta, this is, suppose this O, this is A, this is B, this is B. From triangle OAB, first we find the angle theta. From triangle OAB OB is R, and OA equal to R minus R by 5, which is equal to 4R by 5. OA equal to 4R by 5. Now 4R by 5. Now AB, what is AB? AB equal to root over R square minus whole square, which is equal to 25 TR by 5. Okay, AB equal to this. Okay, now so AB equal to this, OA equal to this. This is V2. So if this angle is theta, then this angle is theta. So velocity V2 in this direction is V2 cos theta, and V1 is along this direction. So V1, that is, wedge moves along horizontal with velocity this. Suppose this is V1, that is V1 equal to 20 meter per second. That is velocity of wedge along horizontal towards left side, towards this, along horizontal. So component of velocity along this direction is V1. This is 90 minus theta. This is theta. This is 90 minus theta. So velocity of V1 along this direction is V1 cos 90 minus theta, which is V1 sin theta. So V1 sin theta will be equal to V2 cos theta. That is relative velocity of wedge relative velocity of wedge with respect to sphere along normal direction is 0. Why? Why? As the sphere is in contact, the sphere is always in contact with wedge. So that's why we can write this. So relative velocity 0 means this velocity is equal to this. So this velocity v1 sin theta will be v2 cos theta along normal direction. So component of velocity along this direction is v2 cos theta, and velocity component of v1 along this direction is v1 sin theta. So v1 sin theta equal to v2 cos theta. Now v1 equal to 20 meter. So v2 equal to what? v2 equal to v1 tan theta. v1 equal to 20, and tan theta, what is tan theta? From this triangle, tan theta equal to perpendicular by base AB by OA, which is equal to AB. What is AB? 3r by 5. OA, what is OA? OA equal to 4r by 5. 20 into 3 by 4, that is 15 meter per second. So this is the answer. V2 equal to 15 meter per second. Now the next question is, a block rests on a rough plane. A block rests on a rough plane whose inclination হচ্ছে না কি a block rests on a rough plane whose inclination theta to the horizontal can be varied. Which of the following graphs indicates how the frictional force F between the block and the plane varies as theta is increased? So 4 diagram are given. Which one is correct? A block rests on a rough plane. Now the solution of this problem: what is the force acting on a inclined plane? What is the force acting on what is the force on the block? What is the force acting on a ball placed in an inclined plane? So force is, we know, mg sin theta. Force, that this is mg sin theta, because mg act in this direction. In this direction is mg cos theta, we know, and in this direction we know mg sin theta. Now net force along this direction, net force along inclined plane is mg sin theta. So frictional force act in the opposite direction, and frictional force when the body is at rest, suppose theta is low, angle theta is very less, then the frictional force is, if the theta is small, then the body is at rest. So when the body is at rest, the friction force is equal to external force. So the external force is mg sin theta. So frictional force equal to mg sin theta. Now frictional force varies according to sin theta. What is the value? What is the graph of sin theta? Graph of sin theta is this. The sin theta graph is this up to 90. Sin theta graph is this, not this, not this, not this. So up to sin theta, up to 45 degree, this is 45 degree. Up to 45 degree, the sine curve is this. Now this is the force is maximum at here. Now after that, when theta is more than this value, then frictional force, this is the maximum value, that is static friction. We know the static friction is maximum, so this is static friction. Up to that, friction is maximum, and as the angle theta is increased above this value, then what is the friction? Friction equal to mu into r, which is mg cos theta. Now cos theta graph will be this way, this and this way. So cos theta graph will be, we know, curve of cos theta equal to this. So this is up to this part is this, as theta equal to 90 degree, cos 90 equal to 0. So frictional force equal to 0 at here. So among these 4 graphs, this option is correct. This is more suitable. First frictional force is mg sin theta. Then when the frictional force exceeds the limiting value, then frictional force value is mu into r, which is mu into mg cos theta. Now this part is cos theta graph, m a mass to m, and this block m is placed, whole system is placed on smooth ground, and if external force F acts on the two block, this force is applied by the string, the whole system move in this direction. The minimum values of mu between two blocks for no slipping. So this block will not slip over this block. What is the minimum value of mu? For this, what is the coefficient of friction? Now if we draw the free body diagram, what is the different force acting? So different force acting T, and this is T, this is T, the direction, this is T. When the external force F act on the system, then the force transmitted in this way. Now the friction force act in this direction first. So this is action, this is reaction, mu mg. Now mg, mu mg. Now here friction force equal to 0. Now as this block is not slipping this, so the whole system move in this direction with a force F force. Now what is that net force acting on the system along x direction? Net force is F along x direction. F here minus t, this and this cancel, plus t. As F equal to t, F A is equal to t, so total force is F. Minus t plus t cancel, so total force is F. So the whole mass of the body, whole mass of the whole system is 2m plus m, 3m into A equal to F. So A equal to ma equal to F by 3. Now as the system moves with an acceleration a, what is the pseudo force act on the block? The pseudo force act on the block is ma, which as the pseudo force act in this direction, so friction force prevents the slipping of the block. Now what is the maximum friction force? Mu mg, which is equal to ma, mu mg equal to ma equal to F by 3, that is mu equal to F by 3 mg. This is the answer. Okay, this is the answer. Now the next problem is a string of negligible mass going over a clamped pulley of mass m supported a block of mass m. This is a block of mass m is supported by string as shown in figure. The force of the pulley by the clamp is given by, this is clamp, this is string, that is this block is hanging from this pulley by string, and the pulley is supported by clamp. Now what is the force acting on the pulley? What is the force acting of the pulley by the clamp? This is clamp, force acting on the pulley by the clamp. So to find the force on the pulley by the clamp, we have to draw the free body diagram of the pulley. What is free body diagram? Suppose this is a pulley and this is clamp. Now when a clamp is present, then the reaction force is always we show at inclined, no horizontal, no vertical. Always force exerted by the clamp on the pulley is inclined, that is action force is always action by the clamp is always at an angle with horizontal. Now resolve its along horizontal and vertical. So this is Rx, this is Ry. Now what is the different force acting on the pulley? Here tension, this string is present, so here suppose tension of the string is T, so here is a T, here is a T. Now the force acting on the block, weight act in this direction, tension act in the direction. Also a weight of the pulley is present, weight weight is mg. So these are the free body diagram of the pulley and the block of mass m. Now the system is in equilibrium, so T equal to, we can write T equal to mg. This is for equilibrium of the block of mass m, and the pulley is also in equilibrium. So summation of fx equal to 0. From this we get T equal to Rx, this equal to this, and summation of fy equal to 0. From this we get Ry equal to mg plus T. Now mg plus T equal to Rx, T equal to Rx. So Ry equal to mg plus Rx. Now T equal to, we get T equal to mg. So Ry equal to, we get this, and Rx equal to T, that is T equal to as mg. So Rx equal to mg, we get Rx and Ry both. Now what is the R? R equal to root over, we have to find the R, Rx square plus Ry square. So Rx equal to what? Rx equal to mg plus Ry. What is Ry? Ry equal to this. So if we take common g, the answer is this. Okay, understand? So this is the answer. This is the answer, m square plus m plus this. So this is the answer. Okay. Simple. We draw the free body diagram of the pulley and this block. This block weight act in this direction, tension of the string in this direction. So T equal to mg, and here different force acting on the pulley is weight of the pulley in this direction. Clamp reaction is R. Clamp reaction is always we show at an angle theta with the horizontal. So this is an angle with the horizontal. Now suppose this component is Rx and Ry. We can write also R cos theta, R sin theta. Okay, Rx and Ry. Now what is, as the pulley is in equilibrium, so we know summation of fx equal to 0, that is T equal to Rx. T equal to Rx. Now T equal to mg, so Rx equal to mg. Summation of fy equal to 0, that means Ry equal to this plus this. So T equal to mg, we put this. Now what is R? R equal to root over Rx square plus Ry square. You can write also Rx equal to R cos theta and this R sin theta. So that's why Rx square plus Ry square equal to R square. So put Rx equal to this and Ry equal to this, we get this is the result. We get this is the result.